Hello ma'am. My first question is why excess air is supplied during the combustion process? How to calculate mass of excess air supplied? Second question, solve one problem to calculate mass of gaseous products formed per kilogram of coal after the combustion process. Third question, solve one problem to calculate the volume of dry constituents of the flue gas found after the combustion of the gaseous fuel.
In previous video, we have discussed how to calculate the theoretical or minimum amount of air required for the combustion process. In this video, we are going to understand why excess air is supplied for the combustion. So, to ensure the rapid and complete combustion of fuel, excess air is supplied for the combustion. Now, how to calculate the mass of excess air supplied for the combustion? Now, we know that after combustion, flue gases are generated. And suppose if there is the unused or excess oxygen found in the flue gases, then from that amount of oxygen we can find out what is the mass of air supplied, excess air supplied for the combustion process. Now we will make here the two parts, that is, suppose here is air and here is the oxygen. Now we have to calculate mass of excess air. So this mass word is important. So we know that there is 23% of oxygen by mass in air. So 23% means what? 23 by 100. So 23 number is for oxygen and 100 number, that is out of 100 amount of air there is 23 amount is for oxygen. So for air I will write 100 and out of 100 there is 23 number is for oxygen. Now how to calculate the mass of excess air supplied? So I will say that here mass of excess air, mass of excess air, that we have to calculate. So here is the question mark. But we know that the amount of excess oxygen that is found in the flue gas. So we can say that here is the excess oxygen found in flue gas. Now if we observe, this excess oxygen found in flue gas is known. So these 123 numbers are fixed and this excess oxygen found in flue gas is also known. Then how we can calculate this? That is the mass of excess air. So it is very simple. So suppose we will consider this as a x, then x is equal to, we will say that 100, that is x multiplied by 23 is equal to 100 multiplied by excess oxygen. Excess oxygen found in the flue gas divided by 23. So we will use this formula. So these three numbers are known, or these three parameters are known. So what is the formula to calculate the mass of excess air? That is 100 by 23 mass of excess oxygen that is found in the flue gases. First I will read what is the given question. A steam boiler uses coal in the furnace. The ultimate analysis of coal by mass as received as carbon 78%, hydrogen 3%, oxygen 3%, sulfur 1%, ash 10% and moisture 5%. Excess air supplied is 30%. Calculate the mass of air to be supplied and mass of gaseous product formed per kilogram of coal burnt. So this was the given question. Let us understand what is the given data. Analysis of coal by mass is given. Hydrogen is 3%. So we can say that it is with mass is given, that is 3 by 100, which is equal to 0.03 and unit is kilogram. Then carbon is 78%, that is 0.78 kilogram. Oxygen is 3%, 0.03 kilogram. sulfur is 1%, 0.01 kilogram, and ash is 10%, that is 0.10 kilogram. Moisture is 5%, that is 0.05 kilogram. Now this is the analysis of coal by mass. Now excess air supplied is 30%. So how we will understand this term? Excess air is supplied is equal to 30% of minimum or theoretical air required for the combustion process. So we have to first calculate what is the minimum or theoretical amount of air required for the combustion of 1 kilogram of coal. So there is the formula. So this theoretical air that we have to find out by mass, because here the analysis of coal is given by mass. So what is the formula? That is 100 by 23 in the bracket 8 by 3C plus 8H2 plus S bracket complete minus O2, unit is kilogram. So this formula is important. Now we will put the value 100 by 23 in the bracket 8 by 3 multiplied by C, that is 0.78 plus 8 multiplied by H2, that is 0.03 plus S. So sulfur, that is 0.01 bracket complete minus O2. So oxygen is also present in the fuel. So we have to subtract this 0.03 bracket complete, unit is kilogram. Now when we solve this, we will get the answer 10.1 kilogram. Now we will calculate what is the excess air supplied per kilogram of coal. So this excess air is 30% of this theoretical air. So 30 by 100 multiplied by 10.1. So when we calculate this, we will get here 3.03 kilogram. Now what is the total air supplied for the combustion process? That is the addition of this theoretical air plus excess air. So we have to add this 2, that is 10.1 plus 3.03, so which is equal to 13.30 kilogram. So this is the answer of first question. Now we will move for the second question. We will calculate the mass of gaseous products formed for the 1 kilogram of combustion of the coal. For that, we have to first understand how the combustion process is taking place. So during the combustion, the elements from the fuel combines with oxygen and the gaseous products are formed. And for the combustion process, amount of air is getting supplied. Now we have seen that for this question, the total amount of air, that is equal to minimum or theoretical air required for combustion plus excess air supplied. So we have to consider all these things. Now if we observe the analysis of coal by mass, then which elements are there that are combined with oxygen? So here is hydrogen that will combine with oxygen and it will produce H2O. Then here is carbon that will combine with oxygen, it will produce CO2, that is carbon dioxide. Here sulfur combines with oxygen and it will produce sulfur dioxide. Now from air, that is from the excess air, there is the excess amount or unused amount of oxygen that will present in the flue gases, or the we can say the gaseous products after combustion. And when the theoretical air is supplied for the combustion process and the excess amount of air is also supplied, then from these two A's, that is theoretical air plus excess air, nitrogen is present in air. So this nitrogen is also the part of the flue gases, that is after combustion it will found in the flue gas. So we have to consider all these things. Now we will first take the fuel analysis when carbon combines with oxygen. Now here this analysis of coal by mass is given. So we will also take here the fuel analysis by mass. So how to take the fuel analysis by mass? For that we have to refer the molecular mass, or we can say atomic mass of the product. Now carbon is having mass, that is 12. Then oxygen O2 is there, and we have to take here molecular mass 32. So when carbon combines with oxygen, it will give us CO2, that is 12 plus 32, that is 44. Now we have to find out the gaseous product, that is CO2, formed for the combustion of 1 kilogram of carbon. So this carbon is having number 12, so I will divide both sides by 12. So how we can read this? That is 1 kilogram of carbon combines with 8 by 3 kilogram of oxygen, and it will generate 11 by 3 kilogram of carbon dioxide. So this is the amount of CO2 for 1 kilogram of carbon. But in the analysis of coal, we have carbon available 0.78 kilogram. So how we can find out the amount of CO2? That is, therefore, amount of CO2 is equal to 11 by 3 multiplied by 0.78 kilogram. So we will solve this and we will get here the answer. Now in the same way we will calculate the H2O. So H2O, that is H2 plus O2, which will give us H2O. So here the single O is there. So we will balance the left hand and right hand side. We will give here the coefficient 2. So again we will balance for the hydrogen. So again we will give here the coefficient 2. So what is the molecular mass of H2? That is 2. So 2 multiplied by 2 plus 32, which will give us, now H2O means what? O is having atomic mass 16 plus H2, that is 16 plus 2, 18. So 2 multiplied by 18. Now again we have to find out the amount of H2O for 1 kilogram of hydrogen. That is for the combustion of 1 kilogram of hydrogen. So I will divide both sides by 4. So 1 kilogram of hydrogen combines with 4 kilogram of oxygen, and it will generate 9 kilogram of H2O, that is water. So how we can write this? That is amount of H2O that is produced during the combustion of coal is here 0.03 kg is given. So 0.03 multiplied by 9. So we have to solve this. Then in the same way we will move for the next, that is the sulfur. So sulfur combines with oxygen, it will give us SO2. So 32 plus 16 into 2, which will give us here 32 plus 32, that is 64. Then 1 kilogram of sulfur combines with 1 kilogram of oxygen, it will give us 2 kilogram of SO2. So what is the amount of SO2 formed? So amount of SO2 formed during the combustion, because S is given 0.01, so 0.01 multiplied by 2. We have to write the answer. Now excess oxygen per kilogram of coal. So here the excess oxygen is due to the excess air supplied. So when there is no any excess air supplied, then all the oxygen is provided by the theoretical air. But here excess oxygen will be found in the flue gas. So how to calculate this? So by mass, there is 23% amount of oxygen is always present in the air. So we have to take 23 by 100 multiplied by the excess air. So which is equal to 23 by 100 multiplied by 3.03 kilogram. So we have to calculate this. Then mass of nitrogen. So this nitrogen is present in the theoretical amount of air as well as excess air supplied. That is, we can say that this amount of nitrogen is present in the total air supply, and this will found in the flue gases as it is. And now by mass it is available with 77% in the air. So we will take here the 77 by 100 multiplied by the actual or total air supply. So total air supplied is the addition of theoretical air plus excess air. So we will write here as a 77 by 100 multiplied by 13.13. Then we will calculate. We can say that after the combustion process, amount of CO2 2.86 kilogram, amount of H2O 0.27 kilogram, amount of SO2 0.02 kilogram. Then excess oxygen, that is 0.70 kilogram, and mass of N2, that is 10.1 kilogram. So these are the gaseous products that are formed after the combustion process. Now we will move for the second question about the volume of excess air supply. I will read what is the given question. A gas fuel has following percentage composition by volume: CO 10%, H2 50%, CH4 26%, O2 3%, CO2 2% and N2 9%. Estimate the minimum volume of air required for the complete combustion of 1 meter cube of the gas. If 50% excess air is supplied, give the volumes of each of the dry constituents of the flue gas. Air contains 21% by volume of oxygen. So this was the given question. Let us first understand what is the given data. Now here the fuel composition by volume is given. CO, that is carbon monoxide, is 10%, that is 10 by 100, so we will say that, which is equal to 0.1 meter cube. Then hydrogen is 50%, so 0.5 meter cube. Methane, that is CH4, is 26%, that is 0.26 meter cube. Then oxygen is 3%, so we will say that, which is 0.03 meter cube. Then carbon dioxide is 2%, that is 0.02 meter cube. Nitrogen is 9%, that is 0.09 meter cube. Excess air is also there, that is supplied with 50%. So we can say that this excess air supplied, which is equal to 50% of theoretical or minimum volume of air required for the complete combustion of 1 kilogram of fuel. So let us first calculate what is the minimum volume of air required for the complete combustion of 1 kilogram of fuel. So we have formula. So whenever there is the volumetric analysis given and we have to calculate the minimum volume of air, we have to use this formula. That is 100 by 21 in the bracket 0.50 CO plus 0.5 H2 plus 2 CH4 bracket complete minus O2 meter cube. Now we will put the values. 0.5 multiplied by CO, that is carbon monoxide, is 0.1 meter cube plus 0.5 multiplied by H2, so H2 is 0.5 meter cube plus 2 multiplied by CH4, that is 2 multiplied by 0.26. Now we have to complete bracket minus O2. So here the amount of oxygen present in fuel, so it is there 3%, that is 0.03. So we have to subtract it. Now when we solve this, we will get the answer, that is 3.76 meter cube. Now what is the excess air supplied? So excess air supplied is the 50% of this amount, that is the minimum volume of air. So we will say that excess air supplied 50%, that is 50 by 100 multiplied by 3.76, which is equal to 1.88 meter cube. So this is the minimum volume of air required for the combustion. This is the excess air supplied. Then what is the total or actual air supplied? So here this total or actual volume of air supplied, we will add these two numbers, that is equal to 3.76 plus 1.88, which is equal to 5.64 meter cube. Now we will move for the next question, that is the dry constituents of the flue gases. Flue gases are generated after the combustion process. So let us first understand how the combustion process is taking place for this gaseous fuel. So these fuels, that is the elements from the fuels, are combined with oxygen and some gaseous products are getting formed. And for this combustion process, air is supplied. Now for this question, the theoretical or minimum amount of air as well as excess amount of air is supplied. So we have to add these two airs, that is the minimum amount of air plus excess amount of air. Now if we observe the elements from the fuel, then here the carbon monoxide is there, hydrogen, methane, then oxygen is present, carbon dioxide and nitrogen is there. Now if we observe the question, the word dry is important. That is the dry constituents of the flue gas that we have to find out. That means we should not take the amount for the moisture, or we can say water, or we can say H2O. We have to take only the dry constituents of the fuel. Now here when CO, that is carbon monoxide, combines with oxygen, carbon dioxide is formed. Then we will not take this H2, because when H2 combines with oxygen, H2O, that is water, is formed, but we have to find out the dry constituents. Then when CH4, that is methane, combines with oxygen, then here also carbon dioxide and water is formed. So we have to consider only carbon dioxide. Then N2, that is nitrogen, is already present, as well as oxygen is already present. Now from the actual air supplied, we have to find out what is the amount of nitrogen, because this nitrogen that will found in the flue gases as it is. So we have to take the total amount of air that is supplied for the combustion process. Then what about the oxygen? So this oxygen, that is the unused oxygen or excess oxygen, will found in the flue gases from the excess air. So from the excess air we have to take, or we have to consider the amount of oxygen. Now here air contains 21% of volume of oxygen that is given in the question. So remaining amount of air, that is 100 minus 21, that is 79% of volume nitrogen is there. So from that we can calculate the nitrogen. Now we will move for the fuel analysis by volume. So CO, that is carbon monoxide plus O2, will give us CO2. Now we will balance here. Now if we observe, there are 3 elements of oxygen on the left hand side and here is 2. So if I balance here with 2, then 2 times of carbon and 4 times of oxygen is there. So here is 2 times of oxygen, O2 is there. So again I will write here 2. Now from this how we can write, that is 2 meter cube of CO will combine with 1 meter cube of oxygen and it will give us 2 meter cube of CO2. Now if we observe, amount of CO is given 0.1 meter cube. Now if I divide both sides by 2, then 1 meter cube of CO combines with half meter cube of oxygen and it will give us 1 meter cube of CO2. So from 1 meter cube of carbon monoxide, 1 meter cube of CO2 is generated. So for this question, the amount of CO is 0.1 meter cube. Therefore, CO2 generated is equal to 0.1 meter cube. Now we will move for the next combustion process when methane combines with oxygen. So when methane combines with oxygen, it will form carbon dioxide as well as water. So we will balance here, that is CH4 plus 2O2 gives us CO2 plus 2H2O. Now we will write this in terms of volume, that is 1 meter cube of CH4 combines with 2 meter cube of oxygen will give us 1 meter cube of carbon dioxide and 2 meter cube of water. But here we have to consider only dry constituents, so we will not consider this water. So what is the amount of CO2 generated? So for 1 meter cube of CH4, 1 meter cube of CO2 is getting generated. So CO2 generated, that is equal to, here amount of CH4, that is 0.26 meter cube. So for this 0.26 meter cube of CH4, after combustion 0.26, that is same amount or the same volume of carbon dioxide is getting generated. Now CO2 present in fuel. So carbon dioxide is already present in fuel, that is equal to 0.02 meter cube. Now what is the total volume of carbon dioxide? That is, we will consider this CO2 generated after the combustion of CO plus CO2 generated after the combustion of CH4 plus CO2 present in fuel. So when we add this, we will get 0.38 meter cube. Now we will find out what is the volume of oxygen. So how to calculate this volume of excess oxygen? So this volume of oxygen that is present in flue gas because of excess air supplied, and this oxygen is not getting used. So it is given that air contains 21% by volume oxygen. So we have to take this 21% by volume of oxygen multiplied by the excess air. So excess air, that is 1.88 meter cube. So 21 by 100 into 1.88, which is equal to 395 meter cube. So this is the amount of oxygen. Now we will calculate volume of nitrogen, that will also present in the flue gas. Now this nitrogen comes from the minimum amount of air that is required for combustion plus excess amount of air that is getting supplied. So we have to take the addition of these two, that means the actual air or total air. So now here 21% by volume oxygen is there, that means remaining percentage is for nitrogen. So we will say that 79 by 100 multiplied by the actual air supplied. So 79 by 100, that is multiplied by 5.64, that is equal to 4.46 meter cube. So this is the volume of nitrogen from the air, but in the fuel also there is nitrogen is present, and which is equal to 0.09 meter cube. So what is the total amount of nitrogen that will found in flue gas? That is 4.46 plus 0.09, that is equal to 4.55 meter cube. So what is the answer? So we can say that the dry constituents of the flue gas are the volume of CO2 0.38 meter cube, the volume of excess oxygen 0.395 meter cube, and here the volume of nitrogen 4.55 meter cube.